Welcome to this demonstration of exploiting the ZeroLogon vulnerability by Toyota Group. Let's walk through the process step by step. To begin, we downloaded the ZeroLogon exploit scripts from a GitHub repository. Since these scripts rely on the Impacket library, we also cloned the Impacket repository to ensure we had all the necessary dependencies. Before setting up our isolated environment, we ensured that Python and its package manager, pip, were installed on the system. We also configured Impacket by running its setup script, preparing it for use with our exploits. Now we copy the contents of the ZeroLogon scripts into the Impacket directory to ensure dependency requirements are met. Next, we created a Python virtual environment which allowed us to manage any additional libraries required for ZeroLogon without needing to modify the domain that the Kali device is managed by. After initializing the virtual environment, we activated it and installed all the necessary libraries by referencing a requirements file that listed the dependencies. Once the setup was complete, we conducted a reconnaissance scan using Nmap. This step was crucial, as it identified the target's NetBIOS computer name and domain name, two key pieces of information required to execute the exploit successfully. With all the necessary details in place, we executed the ZeroLogon exploit script, which targeted the vulnerability in the domain controller, allowing us to reset its password to an empty string and gain unauthorized administrative access. Finally, to capitalize on our access, we used a tool from the Impacket library to extract domain credentials from the compromised domain controller. This step revealed sensitive information stored within the domain, such as the password hash for the administrative account. These credentials could now be used with another Impacket script, which would return a reverse shell. This reverse shell we obtained grants us administrator-level access, as shown here. The whoami/priv command reveals extensive privileges, like taking ownership of files, loading drivers, and shutting down the system. These permissions allow us to execute almost any action on the target system, making this a powerful foothold. Using the reverse shell, we navigate to the user's directory and then into the administrator folder. Here, we have access to files and directories that may contain sensitive information or configuration files. This level of access is critical for post-exploitation steps. And that concludes our demonstration of the ZeroLogon vulnerability exploitation process. Thank you to Dr. Kevza and the rest of the class for a great project experience.